Hi everyone, I'm Xin. I will present our work enhancing ethical explanations of large language models through iterative symbolic refinement. Our explorations focusing on the domain of natural language inference on topic of ethical natural language inference, which is reasoning about everyday scenarios in which individuals perform actions and can positively or negatively affect others. We choose this domain as a representative task to access reasoning in large language models and explore novel methodologies to improve logical validity and alignment. Specifically speaking, the main research interest is focusing on explaining why a given ethical statement is morally unacceptable and generate ethical explanations linking the statements to underlying moral principles. The main challenge here is the ability to perform abstractive commonsense reasoning to connect statements about concrete situations to foundational and unifying moral principles. Let's say there's a statement related to everyday moral scenarios. I feed my neighbor's dog the expired meat. We want to have some explanatory sentences to infer which moral foundation is violated. The explanatory sentences are constructed of grounding facts and lead to an abstract moral principles. Formally speaking, by giving a statement SI, the task is to determine whether SI is morally acceptable through the construction of an explanation composed of some facts. We use the explanation to identify one of a set of moral violations. For such explanation, it is considered to be valid and non-redundant if all the facts are necessary and sufficient for the entailment to hold. Here we are focusing on the explanation generated from large language models. So how can we improve large language models in ethical reasoning and its alignment to underlying moral principles? We propose a neuro-symbolic framework named Logic Explainer to verify and enhance the logical validity, completeness, and non-redundancy of ethical explanations while iterative symbolic refinement. The main contributions are the introduction of a neuro-symbolic framework for multi-step ethical reasoning and explanation generation that integrates large language models with backward chaining reasoning for iterative symbolic refinement. An extensive set of experiments have done on multi-step natural language inference tasks in the ethical domain to investigate the effectiveness of such integration on large language models' explanations. Finally, we leverage the neuro-symbolic integration to build and release a corpus of structured natural language explanations for ethical natural language inference named as Explain Ethics to augment existing datasets and encourage future work in the field. Here is the overall framework of our proposed method. There are two steps involved. For step A, we parse an input moral statement with semantic rules to communicate with the large language model to generate some explanations and hypotheses. At step B, we use an auto-formalization model to transpose abstract moral principles and previously generated explanations into a symbolic format. We then use a symbolic solver to verify the logical validity and redundancy of the input symbolic knowledge base. If it is verified, we state it as a gold explanation. For invalid or redundant knowledge base, we drop irrelevant facts and using an abductive inference model to find any missing facts for the hypothesis, followed by a deductive inference model to find a new hypothesis from refined explanation. We do this as iterations until the explanation is verified by the solver. In the previous slide for step A, we propose a semantic prompting strategy. Since in the ethical domain, moral statements mostly describe daily activities, therefore to elicit an explicit interpretation of actions and their participating roles, the moral statements, like here, I crushed the frog, can be converted into a new Davidsonian logical form, then describe an action, crushed, the agent performing the action, I, and the patient receiving the action, the frog. We adopt this formalism to construct a prompt for a large language model. We use NLProlog as differentiable solver for the auto-formalization. We convert the natural language into the Prolog-style symbolic form. We formalized the violation of moral foundations as the initial goals of the solver. For example, the predicates are moral foundations and the arguments are action and patient. For each initial goal, there are several rules existed prior knowledge. For example here, the rule head states the situation of violating care in physical way are implied from the rule body, which states there is a physical harm made to an animal. Let's say if we have a moral statement, I crushed a frog, with some generated explanatory sentences. Frog are animals. Crush is compression. Compression is the pushing force. The facts, the explanation generated from the large language model, will then convert into prologue rules. The background knowledge, the past semantic rules will convert into prologue facts. There is a weak unification mechanism that automatically build weak rules based on the sentence similarity between two predicates. It is calculated between a head of a sub-goal with the body of the current rule. There is the generated proof tree of the solver. From the proof tree, we can see how the backward chaining reasoning works to prove the goal valid care within the weak unification mechanisms. The generated explanations are transferred into prologue rules, and the semantic rules are standard as the prologue facts. The abductive inference used the previous hypothesis and existing filtered facts to find any missing facts, and the deductive inference then used the refined facts to infer a new hypothesis. We use ethics as our task dataset, which is about ethical-related scenarios. We applied 3 human annotators to re-annotate the dataset for multi-label classification of moral violations, and sampled 166 easy and 145 challenging moral statements, which are distributed across 6 moral foundations. Here are our experiments on studying the impact of strategies on the logical validity of the generated explanations at each iterations. We can conclude that external symbolic solvers elicit valid and complete reasoning. We compared the quality of the explanations produced by a logical reasoner with chain of thought. We found that the percentage of logically valid explanations produced by chain of thought is notably low when compared to logical explainer. Specifically, the results show that explanations from chain of thought tend to include more general facts rather than describing the detailed reasoning process, leading to its predictions. In addition, we found that the symbolic reasoner can help to dramatically reduce the redundancy of the explanations. Besides, we also found neo-Davidsonian semantics enhance logical consistencies in complex sentence representation. As Table 1 and Table 2 shows, logical explainer with no iterations significantly outperforms chain of thought. Chain of thought prompting often fails to incorporate all critical information during the explanation generation process, especially for long and complex explanatory sentences. We also conduct experiments on moral foundation classification tasks. We found that logic explainer can significantly improve the accuracy on moral foundation from 54.5 to 57.6 and 54.1 to 59.1 respectively. At the same time, the results suggest that a significant gap still exists between large language models and human performance in both easy and challenging settings. To understand the effect of the abductive inference step on logic explainer, we compare the performance of different iteration steps. We found that accuracy on moral foundations can improve from 52.8 to 57.6 in the easy settings and 58.3 to 59.1 in the hard setting after additional premises are added to the generated explanation. Logic explainer shows a general trend of positively impacting logical validity, non-redundancy, completeness, and correctness. However, further increasing the number of iterations does not lead to significant improvements. Specifically, The increment in logical validity from iteration 2 to iteration 3 is marginal, showing a 3.1% increase in the easy setting and 3.5% increase in the hard setting. This behavior is mainly caused by the inability of large language models to interpret increasingly complex feedback cycles for longer explanatory chains, and the inability to find new missing facts while abductive inference for completing the explanatory argument after a certain number of iterations, with performance peaking at 2 or 3 iterations. We also conducted a human evaluation of invalid explanations produced by the model by randomly sampling 30% of statements for each moral violation, classifying invalid explanations into two categories. The first one is missing plausible premises, and the second one is no designable arguments. On average, we found that 82.1% of invalid explanations are classified as missing plausible premises. These results suggest that while in-context learning can elicit the identification of coherent arguments to support a given hypothesis, large language models still suffer from incompleteness in their reasoning process. In conclusion, we propose a neuro-symbolic framework for ethical reasoning, integrating in-context learning and external solvers. We propose a validation model to verify the logical correctness. We have significantly reduced the instances of hallucination and redundancy in large language models, benefits from the integration of large language model with symbolic reasoning. In future work, we aspire to enhance the model's inference capabilities concerning challenging model questions. That's all of my presentation. Thank you.